How can you find all the factors of a number? Think about this question during the lesson. 3 possible arrays of 12 buttons are shown below. The arrays can help find all the factors of 12. 1 times 12, 2 times 6, 3 times 4. What are the factors of 12? The factors of 12 are 1, 2, 3, 4, 6, and 12. What other ways are there to show 12 as an array? Flip these arrays on their sides. Other possible arrays are 12 times 1, 6 times 2, and 4 times 3. What would happen if you turned an array on its side? Would you find any new factors? You would find a new multiplication fact, but the factors would stay the same. Would the values still be the same? Yes, the values would still be the same. Let's study these factors further. Arrays can help you find all the factors of a number. However, an easier way is to use divisibility rules. A whole number is divisible by another when the quotient is a whole number and the remainder is 0. Is 85 divisible by 5? 85 is divisible by 5 because the quotient is 17 and there is no remainder. After viewing this example, let's examine the divisibility rules one at a time, starting with the rule for 2. 2. If the number is even. Example, 48 is an even number. 48 is divisible by 2. 3. If the sum of the digits of the number is divisible by 3. 4. If the last two digits are divisible by 4. 4 and 8 are divisible by 4. 5. If the last digit is 0 or 5. 120 ends in 0. 85 ends in 5. 6. If the number is divisible by both 2 and 3. 9. If the sum of the digits is divisible by 9. 18 is divisible by 9. 10. If the last digit is 0. Using the divisibility rules, is 468 divisible by 9? Yes, because the sum of 4 plus 6 plus 8 equals 18, and 18 is divisible by 9. What other divisibility rules apply to 468? The other divisibility rules that apply to 468 are 2, 3, 4, and 6. Use the divisibility rules to determine the factors of 156. Try it yourself.
All right, let's talk about factors. Now, factors are different numbers that can be divided evenly into a larger number. For instance, if I take a look at the number 12 here on the screen, factors of 12 are any number that can be divided evenly into 12 where the quotient or our answer will be a whole number and won't have a remainder. So when I'm talking about factors and factor pairs being two numbers that divide evenly into a number, I can take a look at 12 and I can say, well, I know that 2 and 6 make 12, so 2 and 6 would be factor pairs. I also know that 1 and 12 are a factor pair of 12. 1 times 12 equals 12. And I also know that 3 times 4 are factors of 12. So this would be a factor pair. So when we're dividing numbers, it's really helpful for us to know factors, and especially when we get further into math this year and start working with fractions, it's really important that you're able to look at a number and figure out what numbers can evenly be divided into that larger number. Now you might be sitting there at home thinking, whoa, wait a minute, that's tricky. I don't know how to look at a number and say like it can be divided by 2 or 3 or 4. How on earth am I going to do that? Well, it's actually a lot easier than you think if you have the divisibility rules memorized. And let me show you the divisibility rules. Now, I highly, a lot of highlies, recommend that you guys write this down in your math notebook, print it out, keep it somewhere, and start memorizing it, because this can help you figure out factors. Now, not all numbers are going to have factors. If numbers don't have factors other than 1 in themselves, we call them prime. So for instance, 17. 17 is a prime number. It can only be divided by 1 and itself. And we'll get into that further in this unit. But for today, we just need to be able to look at a number and figure out what it can be divided by. And that's why the divisibility rules come in handy. So what I'm going to do, and I'll show you in a second how we do this, is I'm going to use these divisibility rules to help me figure out what my number can be divided by. Now, here's the number. A number is divisible, which means able to be divided by these numbers if the following conditions are met. So we can divide a number by 2 if the number is even. Remember that an even number is any number that ends, the very last digit, ends in a 0, 2, 4, 6, or 8. So 48, 1,926. Any number that ends in 0, 2, 4, 6, or 8 is even. If it is even, it can be divided by 2. So if it ends in a 0, a 2, a 4, a 6, or an 8, it can be divided by 2 right off the bat. Now, it can be divided by 3 if the sum of the digits is divisible by 3. So let's think back to 12. So if I think about 12, I want to add the digits together. So I have 1 plus 2. That equals 3. If the sum of the digits can be divisible by 3, then that number can be divisible by 3. Well, I know 3 can be divided by 3, so 12 has to be able to be divided by 3. Let's try that with a larger number. So if I had, for instance, 48. If I take the 4 and the 8 and I add them together, that gives me 12. I know 12 can be divided by 3, so 48 can be divided by 3. So a number is able to be divided by 3 if when you add the digits together, that number can be divided by 3. We'll practice that in a couple seconds. Number 4, if the last 2 digits, a number can be divided by 4 if the last 2 digits are divisible by 4. So 348, 48 is divisible by 4. So I can do 348 divided by 4. So if the last 2 digits are divisible by 4, then you can divide the number by 4. For instance, let's try another one. I can do 312 can be divided by 4 because 12, the last 2 digits, 12 can be divided by 4. So see how the divisibility rules help you out? I already know, oh, that's pretty easy. I can do 2, 3, and 4. Moving on, a number can be divided by 5. This is a super easy one, and you guys should already know this. A number can be divided by 5 if it ends in a 0 or a 5. So 435, it ends in a 5. It can be divided by 5. If I have 920, it ends in a 0. It can be divided by 5. So if it ends in a 0 or a 5. Now, a number can be divided by 6 if it can be divided by 2 and 3. So if you have a number that's even, can be divided by 2, and the sum of the digits are divisible by 3, then that number is also divided by 6. The reason being, if you think of it, 2 times 3 equals 6. So that's why if you have both of those conditions, it can be divided by 6, like 12. 12 can be divided by 2 because it ends in an even number. And if I add 1 and 2 together, that gives me 3. So that can be divided by 3. Since 12 can be divided by 2 and it can be divided by 3, 12 can also be divided by 6. And we'll practice these in a few seconds, so don't get overwhelmed. Moving on to 9, a number can be divided by 9 very similar to 3 if the sum of the digits is divisible by 9. If the sum of the digits is divided by 9. For instance, if I have 189, 1 plus 8 is 9, 9 plus 9 is 18, 189 can be divided by 9. So when you add them together, 1 plus 8 plus 9 gives me 18. 18 can be divided by 9. Now, on a side note, 18 is also a multiple of 3, so 189 can also be divided by 3, but that's just going back to 3. So the divisibility rules kind of help you figure out what a number can be divided by, helps you to figure out factors. Definitely memorize these and use them. Last but not least is 10. That's really easy. If a number ends in 0, it can be divided by 10. So use these numbers to help you figure out, use these rules to help you figure out if a number can be divided, by any of these factors. Now, let's take a look at some numbers. Here's how I do it. Say we want to find all of the factors of 48. Here's how I recommend that you do it. Write the number 48, underline it, and then I want you to make a T-chart. A T-chart is basically when you take a line and draw it in half. If you look, it forms like the letter T. What we're going to do is we're going to start with the number 1, and we're going to count one number at a time. We're going to apply the divisibility rules, and we're going to see if they work for 48, and we're going to write them down as we go. So I'm going to start with 1. I know that every single whole number can be divided by 1, so I'm going to write down 1, and then 1 times what? So 1 times what equals 48? Well, I know that that factor pair would be 48. So 1 and 48 is a factor pair of 48. 1 times 48 equals 48. So now from 1, I'm going to count up 1, 2. So 2, since this number is even, it ends in a 0, 2, 4, 6, or 8. I know that it can be divided by 2. So 48 divided by 2 equals 24. Now let's try 3. Well, I learned in the divisibility rules that if I add those digits together and they equal a multiple of 3, they can be divided by 3. So 4 plus 8 equals 12. Since 4 plus 8 equals 12, and 12 is a multiple of 3, I know that 48 must be able to be divided by 3. And it can. It goes in 16 times. So 3 times 16. All right, let's keep going. So let's try 4. I learned that if the last two digits, in this case 48, can be divided by 4, then that number can be divided by 4. Well, 48 can be divided by 4 because 4 divided by 4 is 1, 8 divided by 4 is 2, so 48 divided by 4 gives me 12. So here I'm just making a T-chart. I'm counting in order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm writing down whatever the pair is across from it. So this times this equals my number that I'm working with. So 3 times 16 equals 48. All right, so I did 1, 2, 3, or 4. Let's go on to 5. So 5 says that if it ends in a 0 or a 5, it can be divided by 5. Well, 48 doesn't end in a 0, and 48 doesn't end in a 5. So we can't divide it by 5. 5 doesn't work. So let's get rid of that. How about 6? Remember, we learned from the divisibility rules that it can be divided by 6 if it can be divided by 2 and 3, both of those. Well, it can be divided by 2 and it can be divided by 3, so it must be able to be divided by 6. And 48 divided by 6 equals 8. All right, let's go to 7. There really isn't a divisibility rule for 7. It just kind of requires you to know your 7's times tables. I know that 7 times 7 equals 49, so I know that 48 can't be divided evenly by 7. There's not really a trick for that one, unfortunately, though. So 7's and the 8's tables, you kind of have to know on your own. Now, when I'm doing my t-charts and I'm figuring out my factors, I'm going to keep going until my number here circles over to my number here. So if I take a look at this, 6 is only one number away, well, 2 steps away, one number in between from 8. So I know that 7 is in between those numbers. Now, since 7 isn't a factor, I know that I'm done. These are all of the factors. Once your number here gets close to your number over here, or is the same as your number over here, you don't need to go anymore. And the reason being, if I keep going, if I do 8, I get 8 times 6. Well, I already have 6 on my factor tree, or my factor list, so I don't really need to keep going. So you're going to keep figuring out your factors until you get to a point where they're right next to each other, or there's nothing in between them. 6 and 8, the only thing in between them is 7. 7 doesn't go into 48, so I'm done. Now what I'm going to do is write out a list of my factors. These numbers are all factors of 48. That's a complete list of the factors of 48. If I write them in order, I get the factors of 48 are 1, 2, and I'm just going to write them like this. Write them in this order. So go down and come back up. So 1, 2, 3, 4. I'm just copying them. 6, 8, 12, 16, 24, and 48. Those are all of the factors of 48. Those are all of the numbers that can evenly be divided into 48 without there being a remainder. Now, you may not have known some of those off the top of your head. You may not have known that 48 divided by 3 equals 16. And that's why it's really helpful to use the divisibility rules. Let's try another one. So let's try to find all of the factors of 30. So I'm going to start by writing 30. I'm going to underline it and make a T chart. Now, in order to fill it out, all I'm going to do is start with the number 1, and I'm going to keep figuring out my factors based on my divisibility rules until my numbers kind of circle back to one another. So I'm going to start with 1. Everything can be divided by 1. 1 times 30 equals 30. So it's whatever you multiply by to get 30. Now let's take a look at 2. Well, 30 ends in a even number, so 30 must be even. It ends in a 0. 0 is an even number. So 30 divided by 2 gives me 15. Let's move on to 3. If the sum of the digits can be divided by 3, then it's divisible by 3. 3 plus 0, if I add them together, 3 plus 0 equals 3. And I know that 3 can be divided by 3, that equals 1. So 30 can be divided by 3. That gives me 10. What about 4? In order to be divisible by 4, the last 2 digits have to be able to be divided by 4. Well, 30, I know, isn't a multiple of 4. I can do 28 and I can do 32, but 30 doesn't evenly go into 4, so I have to erase 4. It doesn't work. How about 5? If it ends in 0 or 5, it can be divided by 5. 30 ends in a 0, so 30 can be divided by 5, and that gives me 6 times. Now, I know that I can stop because here my numbers are right next door to each other. 5 and 6 are right next to each other on a timeline, so if I keep going, I'm just going to circle back and start getting these numbers again. So now that my numbers are right next to each other, I can stop, and I have all of my factors. My factors of 30 in order. Remember, you start by writing them in order down and then circling back up. 1, 2, 3, 5, 6, 10, 15, and 30. Those are all of the factors of 30. Let's try one more, and then I'll let you guys practice it on your own. So, what I want you to do is I want you to see if you can figure out all of the factors of 32. Go ahead and pause the video. See if you can write your own T-chart, figuring out your factors. And then once you think you know all of the factors, hit play, and you can see if you get them all right. I'll go ahead and give you guys a couple seconds. So hit pause now, and then go ahead and try to figure out your factors. All right, let's see if you got the factors right. So I always start with 1. I'm going to count by ones, 1, 2, 3, 4, 5, 6, and I'm going to see if my numbers fit the divisibility rules. Here I'm trying to figure out the factors of 32. So I'm going to do 1. I know that that's a factor of 32. 1 times 32 equals 32. Now how about 2? Well, 32 is an even number. It ends in a 0, 2, 4, 6, or 8, so I know it can be divided. And 32 divided in half gives me 16. Let's try 3. Well, we know that a number can be divided by 3 if the sum of the digits is divisible by 3. If I add 3 plus 2, I get 5. 5 can't be divided by 3, so 32, 3 isn't a factor, so we have to erase that one. Let's try 4. I know that a number can be divided by 4 if the 2 digits in that number can also be divided by 4. 32, I know my 4's table, and I know that 4 times 8 equals 32, so I know that 32 can be divided evenly by 4. How about 5? The divisibility rules say that anything that ends in a 0 or a 5 can be divided by 5. 32 doesn't end in a 0, and 32 doesn't end with a 5, so it can't be divided by 5. How about 6? In order for a number to be divided by 6, it has to be able to be divided by 2 and by 3. This number can't be divided by 3, so it can't be divided by 6 either. So let's cross that one off. How about 7? There's not really a secret for 7. There's not really a divisibility rule for 7, so I kind of have to know my math facts. And I know that 7 times 5 is 35, 7 times 4 is 28, so 32 is not able to be divided by 7. Now if I keep going, 8 is already on my list. 8's already a factor. So since I've circled around to the right side of my T-chart, I'm done factoring. There aren't any other numbers that can be divided by 32 because now I've started working my way up the chart on the right side. So here are all the factors of 32. I'm just going to copy them down, starting by writing down and then copying the numbers up, going up, and I'll end up having my list in numerical order. 1, 2, 4, 8, 16, and 32. All right, definitely make sure that you're either writing down or printing out a copy of the divisibility rules and that you're reading it a few times so that you start to memorize it. If you know the divisibility rules, they'll help you figure out factors, and you're definitely going to need that for some of the math that we'll be doing this year. Good luck, guys. Don't forget to try your practice problems and let your teacher know if you need any help.